it would be an impossibility to even think the whole world. There's a few people pulling this off, somehow fooling the whole world, all the scientists and everything who study for their entire careers. Somehow, none of them are smart enough to figure out that the world is not really what's going on around them.
Okay, yeah, and if you or I were back in 400 AD, you'd be looking
I
around
don't
and
care
saying to
about
me,
400 AD. This is
how
not
would they be
400
lying?
AD.
Dude,
This is
it's like
nowadays.
it doesn't matter. It's the human psyche that I'm referring to. It's the specific time has got nothing to do with it. It's just two fellas having a conversation
Of
about
course,
whether or not the society at large is lying to them.
Yeah.
Now, you would
yeah, but
say
in
upon
400
review, looking
AD, the
back,
majority.
wait, 1 sec.
In
Looking
four,
back into history, you would have said that the Catholic Church was manipulating those people, and in the current paradigm, it's all truthful. All the society, like what they're working towards, is all truthful. But back in that day, you would happily acknowledge. I mean, given your current paradigm, where you're looking back into the past, a retrospective view, you can easily say that that was all lies.
Yes.
Yeah, cool. It's surprising to me that you can't actually sort of. I think that there's an imagination there that's required.
No.
This has got nothing to do with being stupid. It's I mean, equally as you may want to call us or me stupid and not smart enough or something. I would say that perhaps you maybe lack imagination and understanding of how the society has been built around you. I'll end with that. Anyone else want to jump in? Go ahead.
Let me just say real quick before you jump in. Let me say real fast. I think that if we were in 400 AD, but we knew what we knew now, or maybe even way further back than that, religion wouldn't have got such a stronghold. Religion got such a stronghold because the knowledge was so small back then. Knowledge was so inferior
How do you
back
know?
then. So many people were illiterate. So many people. There was no technology. There was no things like internet and computers and shit like that. Everything was bare bones basic. That's
History is
what
bunk
allowed it.
coal.
People
It's a
died early.
lie.
People suffered a lot more back then. There was no medicine like
How
there
do you
is
know?
today and everything
Wait,
else.
Dude,
how do
So
you know
Cole,
that? How
history
do
is a
so
you know that?
lie,
You wouldn't lie.
and you even said before, Cole.
because of all of that, that's why I think that religion was able to take such a stronghold and people believed it so hard because their lives were so hard that they wanted something to believe in. If we had modern day technology at the beginning of religion, I don't think religion would have took hold.
Wait, Cole, do you believe in the vacuum of space?
Yes.
You know that the vacuum of space violates all the gas laws and the second law of
No,
thermodynamics,
it
right?
doesn't.
Yeah, it does. So if
No, it
we're
don't.
inside of a car, if we're inside of a car and I spray gas in the car and I open the sunroof, what happens to the gas molecules?
Well, considering you got air all around you whipping by, are you meaning the car's driving or what? Because I can explain this in a
But
little bit better detail to allow
if
you
we are
maybe
in
to
the car,
understand it.
if we are in the car and I spray gases in the car, I open the sunroof, the gas will escape.
Okay, if you got a ball and everything is pulled towards the ball, vacuums don't suck. Vacuums do not create a
Right?
suction force. So if
Yes, they do.
everything is no, they do not. What's in a vacuum that
So
creates a suction force? Yeah,
high pressure, low
no,
pressure,
no,
high pressure,
no.
low
Let me
pressure.
talk. Hush. A pressurized
Okay.
system is basically a bunch of molecules that are compressed together. A vacuum is no molecules.
Right. And high pressure system.
The reason the pressure always pushes into no pressure is because those molecules are trying to push apart. So they pushed themselves into the area of no molecules. There's nothing in the area
Right.
of no molecules that's sucking anything. There's nothing there.
Right.
There's nothing there
So you
to
just said.
create the suction force. It's
So you
empty.
just said. So
Empty
you
does
just
not
said.
create. No, if you'll be quiet, I'll get there. Empty does not create a suction force. So if you have a planet and the only thing going on that planet is things are being pulled towards the planet much harder than the force of the molecules can push apart, and there's and suction there, the vacuum is not sucking them off because vacuums don't suck, then all of the air will cling to that planet because there's no force pulling it off. There's only a force pulling it down.
Okay, number one, your current paradigm is not gravity pulling things down. That's been outdated. That's Newtonian old gravity
I don't care
mechanics.
what
It's
you want
now
to call it.
situated
Things
like
go
this.
toward the
I'll let
surface.
you speak. I'll let you speak. So your current paradigm is not a pull of gravity anymore. You're 100 years out of date. Number two, high pressure seeks low pressure always, and you agreed with that. That's what you said. Number three, a vacuum cleaner creates a low pressure system in the container, and then high pressure seeks low pressure to create the suction. Now, you claim that the globe is basically an infinitesimal small dot in an infinite space vacuum. Then that would mean the high pressure gas at sea level would rapidly expand into the vacuum and you'd be dead.
Wrong. Because
Okay,
there's more than one
then you
force.
don't.
There's more
No,
than one force. You stopped. Let me start. There's more than one force. The force of the molecules
gravity's not
pushing apart, the force of the molecules pushing apart are a certain strength. The force of gravity is a much greater strength. So the force of the molecules pushing apart are not strong enough to expand into space because the greater force of gravity, which is much stronger than the force of the molecules pushing apart, pulls them back together towards the ground. I don't care if you don't say gravity pulls. I don't care what you say. Everything falls to the
okay.
ground when you drop it. Even air. The air
Even
is
a
made up
helium
of
balloon.
air is made up of mass. Helium balloons rise because they got buoyancy. The buoyancy is caused by the gravity of the Earth
Incorrect.
pulling the heavier air down around it, which means it pulls it down around it, pushing the helium balloon up. There's more than
Okay.
one force acting upon it.
Okay. So let me
You
ask
got
you a question.
buoyancy
Let me
and
ask you a
gravity.
question.
But
Let me
the
ask you a
air,
question.
but hold on. You mentioned a vacuum cleaner. A vacuum cleaner does not just create a vacuum. It takes the air on the inside of the bag and it blows that air out, which means the air on the outside then it pushes itself in. That's what creates the vacuum. It does not create a vacuum that sucks. Vacuums do not suck.
I
These
never
are
said
well
that. So
understood sciences.
again, I said the vacuum cleaner creates a low pressure system, and due to entropy, the high pressure seeks low pressure. That's what that effect is. Now, number two, you keep saying gravity pulls things down. Again, that's wrong in your paradigm. You don't even know your own belief. Number three, gas molecules move randomly in all directions. They don't move down. Now, do you claim that gravity holds gases only down, and that gas molecules only move down? Yes or no?
Gravity pulls down on them.
Oh, okay, great. So when you fart, right, does it disperse in all directions, or does it drop to the floor?
They try to disperse in all directions, but they're not strong enough to overcome the pull of gravity and fly out into space.
So when you fart, you didn't answer the question. When you fart, does it disperse in all directions, or does it drop to the floor due to gravity?
Well, it depends on what gas you got. Some gases do fall to the floor.
Some gases do fall to the floor.
Yes,
So when
some
you, again,
gases
you
are
didn't answer,
heavier than air and they flow on the
when
bottom of the
you,
floor.
well, that's incorrect because you guys claim to have a
That's
ozone layer.
incorrect. You sure
And the
about that?
ozone. Can I finish? Yes, I'm very sure about that. So gas molecules move randomly in all directions. You guys claim to have an ozone layer. Ozone is more dense than air. So according to your own paradigm, the ozone layer would be on the floor.
No,
What you just said, that the ozone layer being more dense would be on the floor, not in the air. So number
no.
three, um, gas particles move randomly in all directions. They don't only just move down; they move randomly. They move up, down, sideways, or diagonal, every direction, and they fill available space. Now, yes or no? Does high pressure gas seek vacuums always? Yes or no?
Does high pressure gas do what? Say it again.
Let's say if I have a container of gas on one side, a valve, and then on the other side I have a container of vacuum. If I open the valve 100 times out of 100 times, does that gas rush into the vacuum? Yes or no?
Yes.
Great. So you have your Earth, that's an infinitesimal small dot in an infinite space vacuum, and all of the air on Earth should rapidly escape into the vacuum, and you'd be dead.
No.
According, you
That's a
just agreed
complete.
with me.
You're comparing two completely different things. You got a very high pressure trying to push into a vacuum. If you had the same
Right.
amount of pressure that our atmosphere has, and you had it down on the surface of the planet, and you had the vacuum all the way up high, and you had a container that stretched from the ground all the way up, the gas that would be down near the surface would not rush all the way up into the vacuum that's 30 miles in the air up in the sky.
Really?
That's not how it
Are
works,
you serious?
really, because
Are you
even though
serious?
you keep saying that gas pressure goes in all directions. It's like a spring. It's being
That's
compressed.
called entropy.
It's being compressed down near the surface from its own weight, because mass has weight, and air and gas are mass. They're being compressed
If,
by their own weight. They're like compressing a spring. But them trying to push each other apart is not stronger than the force of gravity trying to compress them down toward the surface. Since they have weight,
okay,
they're being squeezed towards the surface. They are not strong enough to push themselves out into space
okay.
because they're being
Is
pulled
gravity
harder towards the ground.
great? Is gravity a container for gas?
Is gravity a container for gas? I
Yeah,
guess
is
you could
gravity what
say
is,
it's. If you want to say gravity's a container, I guess you can. It
no,
holds.
I'm
It holds
asking
gas
you.
to the planet.
Are you claiming that gravity is a container for gas on the Earth?
I'm claiming that it holds gas to the planet.
Can you prove that? If I give you a container of gas and I put gas in there, can you show me in an experiment where you can manipulate gravity to pull those gas molecules down to the bottom of the container? Can you show me that?
Yes, yes.
Okay, great. So please show me someone in an experiment who's done that.
Show you a
I'll give you
vacuum
a.
where they show you a vacuum where they
By the
release
way,
the gas and it
if you
settles on the surf on the bottom.
oh oh oh, if you can show me
That's
someone
easy
manipulating
done.
gravity, if you can show me someone that's isolated and manipulated gravity and pulled molecules down to create more pressure on the bottom of a container, I'll give you $1 million. If
You
you can
don't
show
have
me
$1
that.
million, but it's not
How
hard
do
to
you know
show
what
a
I have?
vacuum. It's not hard to
How do
show
you
a
know what I
vacuum
have?
with a heavy gas that settles on the bottom.
Cole, that's not what I said. I said to you, you said gravity pulls gas down and holds it to the earth. Can you prove that in an experiment? Show me someone that has a container of gas. I'll give you the container because you can't do it without a container anyway. So I'll give you the container. We've got two gas gauges, one at the top of the container, one at the bottom, and there's gas in there. Can you show me someone that's isolated gravity and used it to pull those gases down to create more pressure on the bottom of the container? I'll
You
give you
don't
$1
have to.
million.
You don't have to isolate gravity,
So then how do you prove it's pulling gas down?
because if you put it in there and it only settles on the bottom and it don't fill the tank
No,
evenly, then it's being pulled down.
no. So a pressure gradient exists due to a dynamic system in the container. You can recreate a gas
Right,
pressure gradient in a
right,
container. You know that the only way to have a gas pressure gradient is within a container, right?
right. So you say.
Right. So then if we have a gas pressure gradient on Earth, it's contained automatically. Also,
No, no,
in order to have a
no.
vacuum, I wasn't done. In order to have a vacuum, you need a container as well. Can you show me someone recreating a vacuum using gravity and sustaining it without a container, please?
Using gravity without a container. No, because we exist in a
Okay.
pressurized.
So
We
then,
exist in pressurized air.
so then you can't prove.
You're asking for something in an environment where it cannot be done.
Right. So then you can't prove that the vacuum of space exists the way you claim. Then, can you? You can't
Yes,
scientifically prove it, can you? Oh, you
yes,
can. So now show me
yes.
someone recreating a vacuum without a container using gravity. Go.
You don't have to recreate a vacuum using gravity
Yes, you do. Is that what you're
to show it.
okay?
I mean, literally the gradient of the atmosphere itself. You can launch a balloon that'll go all the way up to the edge of the atmosphere and the pressure will pretty much read zero at the top of the atmosphere,
Great. What creates
showing that there is air on the bottom, no air on top. Why is that air on the bottom not expanding to fill the
what
void
what
up
what
top?
creates
Tell me that.
what creates the pressure? What creates the pressure gradient on Earth?
You said all gas will fill to expand the volume. So why is the air near the
No,
bottom, near the surface, not expanding to fill the air at 20 miles up?
it is. It is, but it's in
No,
thermal
it's not. There's a
equilibrium.
pressure gradient.
Can I finish? The only way to have a pressure can you have a pressure gradient without pressure, Cole?
The pressure is caused by the weight of the air.
Okay, I'm going to ask again. Can you have a pressure gradient without pressure?
I don't even know what that means. Can you have a pressure gradient
Okay, let me make it
without
simpler.
pressure?
Yeah, can you?
I don't even know if that question even makes sense.
Okay, let me make it easier for you. Can I have a red car without the car?
No.
Okay, so can you have a pressure gradient without pressure?
Okay, we know that we have a pressure gradient.
I just destroyed you.
No, you didn't. We know that we have a pressure gradient. You yourself said gas will expand to fill the volume. So why does the thicker gas not expand to fill the thinner gas up above
All
and
right,
all equal out? I
let me
just
explain it then.
destroyed you,
So
big boy. Those were
the only
your
way to have
words,
pressure,
and now you can't
the
answer
only way
that.
to have yeah, I can actually. So the only way to have a pressure gradient is with pressure. So just the fact that it's less pressure up there doesn't mean it doesn't need a container. It still needs a container. It still has pressure, right? The definition of gas pressure is the amount of force exerted by the particles on the walls of a container. Without a container in the sky, you can't have that pressure. So we have a pressure gradient because the Earth is a dynamic system. We have a sun and moon that moves over top of the Earth, heating up different portions and cooling down different portions of the Earth. It's in constant motion, and the higher up you go in altitude, it gets colder. Therefore, the gas pressure would decrease because it's Gay-Lussac's law. Pressure decreases with temperature. So as you go higher, it gets way colder. That would decrease the pressure. The particles would not move as fast and they would create a lot less collisions with the
That
container, creating less pressure. So I can demonstrate in a container a pressure gradient inside of a container using temperature. And I can go outside and point to the sky and say, oh yeah, look, a pressure gradient, therefore it's contained. Now, can you do the same with gravity?
And this is why that won't work for you, because when gas gets colder, it gets thicker. And it condenses. When it gets warmer and hotter, it gets thinner and it spreads out. But guess what? As you
Right.
go up and it gets colder, it don't get thicker. It still gets thinner.
Yeah, because of the so
Yeah.
again, all the gases at surface are introduced at surface level. So naturally, there's just going to be more gas
Why are
particles at
they
surface level.
introduced at
And
surface level?
are there trees and oceans in the sky?
No. But that don't mean
Great.
that's where
So
the
where does
gas
that?
is introduced at.
So you think gases are formed in the sky and come down to the Earth?
They're not formed at all. They're here.
They're not formed. They're not formed.
No, they were formed a long
They're here.
time ago.
So they're on Earth, though, right? You know that oceans create oxygen, right?
Yes.
So then the oxygen molecules are created at the surface of the Earth.
Yes, and you know that it rains and
Okay.
everything else, and it comes back down to the ocean, right?
Yes.
All right. So the gas, it ain't like the gas is created. The gas just transforms and goes in a cycle.
Exactly, which is exactly my
Exactly. So
point. Yes,
meaning it's
the
not
Earth is a
created at the
dynamic system.
surface. It's just a
Yes,
cycle.
it is. Yeah, it's a cycle, which means the Earth is a dynamic system. And again, when you get a container of gas and make it a dynamic system, it's going to have a gradient. Now, again, I'm going to ask you. You said that the gas pressure gradient is created by gravity, but you can't prove it, and I can. So, I can go outside, point to the sky, and say, "Oh, look, a gas pressure gradient. Therefore, it's contained." And I can prove my example with an actual experiment, and you can't. Can you admit that you can't show me someone manipulating gravity to cause a gas pressure gradient? Can you admit that?
You don't have to manipulate gravity to cause a gas pressure
So you
gradient.
can't. So you can't scientifically verify what you're claiming, then, can you?
Well, I guess you could say you could manipulate gravity, but you're not manipulating
Well,
gravity.
how? How?
You can put something in free fall, and you can watch it go from being basically layers to basically jumbling up all mixed up, and then when it gets to the bottom and it can't fall any further, it'll sort itself back out into layers again.
Um, again, you can't show me someone
That's not
recreating
manipulating
gas
gravity.
pressure. You can't. Okay, so then you can't show me someone recreating a gas pressure gradient with gravity, can you?
Recreate, yes, everything. You can recreate gas easy. You can recreate that easy
That's
with
not my
gravity.
question.
What are you
Not my
talking about?
question. Not my question. Again, you're obfuscating now. I'm asking. Your
What are you
claim
saying?
is
You want somebody to
your
create
claim is
gravity?
no.
I
Your
can make a
claim is
centrifuge and do it.
your claim is a centrifuge is contained. So thanks for proving the firmament. So okay, let me go. So you're saying again that the gas pressure gradient is correct. You laugh, but you gave me a contained example, so you just proved the firmament. So thank you for
No,
that.
I
So
didn't.
again, can you show me a gas pressure gradient being recreated with your gravity belief? Yes or no? If you can't do that, you can't scientifically
Yes,
verify
that is
claim.
extremely easy. Any
Okay,
tank,
great.
any tank, anywhere on the planet right now, any tank has a gradient in it caused by gravity.
How did you
There you
isolate
go.
gravity to
There
verify?
you go.
How did you isolate
You don't
gravity to
have to
verify that?
isolate gravity to do it. Gravity's
Oh, so
gravity.
you
It's
can
there. It's all
so,
around us. It's everywhere.
so you
Everything
can
drops to the
just
ground.
presuppose it.
You
So
don't
you just
have to make it.
presuppose it.
No, you don't have to make it lighter. You don't have to change it. You
What?
don't have to do any of that. Gravity
You
pulls
know, just
everything to the
observing.
ground. You have a tank, and it has a gradient inside. That's gravity causing
Did you
a
just say?
gradient.
Did you just say gravity pulls things to the ground? What you mean, like a
You,
helium balloon?
a helium balloon has another force that pushes it up. Gravity is still
So if
trying to pull the
gravity,
helium balloon down, but it has another
oh,
force because more than one force can act on something at one time. I know you don't get that, but
I
everything
do
has
get that.
more than one force
Promise.
is acting upon it. So even though gravity is pulling down on the helium, it's pulling
Can
down
you prove that?
harder. It's pulling, would you quit interrupting me? It's pulling down harder on the air around it. Since it pulls harder on that air than it does the helium, that air pushes the helium up.
You can't prove that though. Can you prove that? Can you isolate gravity to
Yes,
prove
that's
what you
been
just
well
said?
proven.
Okay, what experiment verified that you can use gravity to pull gas down? Name the experiment. I'll go look it up.
I don't know. I'd have to look it up. I'm sure that there's
Oh, so
been a
you don't.
bunch of them,
So you make
but it's
positive
caused by
claims.
it's caused by
Hang on a
buoyancy.
sec. Oh, now I'm talking. So you make positive claims, but you can't verify. You just lie about that. Then
You're
basically.
just denying science. That's all you're doing.
No, I'm not. Hang on a second.
At
What's
least
the
my claims are
necessary
backed by
antecedent?
science.
Really? So what's the necessary antecedent to
Yeah,
gas
really.
pressure?
The necessary. I don't
What's
know. You tell me.
a container? So who's denying science? What do you think the V for volume in the gas laws is?
Okay, gravity acts as the container. You do
Great. Can you
realize
bring
that,
me
right?
5 liters? Great. So bring me 5 liters of helium with gravity, please. Can you do it?
Bring you 5 liters of helium. If I was in if I was in space, I could, but I'm
If
not in space.
if
I'm on
you
a giant ball that has its own gravity, so I can't do it
wait.
here. I would have to be
So if you,
somewhere that I'm not. I would have to be somewhere that's not already
wait, wait,
being acted upon by a gravitational object to do that.
wait. So if we were in Narnia, you could bring me 5 liters of helium without a container using
We don't
gravity.
have to be in Narnia. We could be in space.
So if we were in space, a place that you haven't verified exists, you could bring me 5 liters of helium without a container.
Yes.
Okay.
You
So
said
yeah,
using gravity. You said
that's
using
literally
gravity. You said
that's literally
could
the
I use
that's
gravity?
literally the
No,
that's literally the R word.
your question was could I use gravity to bring you 5 liters of helium? Yes, I could. If we was in space and we was not
Oh,
anywhere
really?
near a gravitational object, I could get something heavy enough that it would create its own gravity and it would hold 5 liters of helium around it. It would hold
Wait,
that helium to
wait,
itself,
wait,
and
wait,
then I could give that
wait,
to you, and that would be me using gravity to give you 5 liters of helium.
wait.
But
You
we
could
can't
isolate
do it as
gravity.
long as we're in the gravitational field of another
You,
body.
you could isolate gravity
So you don't think
and
these
use
things
it.
through before you blurt
And
them out.
again, you could isolate gravity to on the Earth to bring me
No,
helium.
see,
Five
you
liters.
didn't listen to a word that I said. Not
Hang
a
on. I did
word.
listen to you. You can't go. Can you go to space?
I
Can
just
you go to
said that I
space?
couldn't do it
Can you go to
in
space?
the gravitational field of a large object like
All right.
the what
So
we're
you
on.
can't do it on Earth. You can't prove it scientifically on Earth. You have to be somewhere else that doesn't exist. They haven't proven yet.
Nowhere in science does it say things have to be proven where you want them to be proven.
Wait. So can you verify? Can you prove your claims? You can't prove your claims. You just can say them. You can just say to me that gravity holds things down like gases when they move randomly in all directions. And then I ask you, can you scientifically verify that with an experiment? Like that's what fucking science is. That you say you
You
agree with
wouldn't know
science,
science. How do you
Yeah.
know
you're denying
science?
science.
How do you
Yeah,
know
you're
science?
denying
Hold
science.
on, NASA. Let him finish. Then I'm
How
gonna
do
Yeah,
let
you
you
you're
know
go.
denying
science?
science. Can you be quiet, NASA?
How do you know
Now,
science?
So so you're claiming that gravity's holding gases down to the Earth, but you can't verify that in an experiment, correct, Cole?
now I'm going to say one more thing. There's no caveat in science that says that Doing an experiment and proving something has to be cheap, has to be easy, or has to be available for every single one of us laymen to do. Nowhere does it say that.
Can you do the scientific method to prove what you're claiming? Can you use the scientific method to verify that gases can be held down using gravity? Can you scientifically use a scientific method to prove that?
Humans can.
I mean, I could.
So show me the human. Show me the human that's.
There's a density. There's a gravity. There's a atmospheric density gradient. The lower you go, the higher the pressure.
Great. So can you prove to me that in a container, gravity can be isolated and manipulated to move the gas molecules down to create a gas pressure gradient inside of that container? Can you show me someone doing an experiment to prove that?
Every container has a gradient.
So you just proved the firmament. So every container has a gradient.
No. You get a container of oxygen on the table will have a gradient in it. The lower the pressure, the lower you are.
We're gonna flat Earth.
Grade the pressure.
Thank you.
No. How does gravity work on the flat Earth?
Thank you for proving the firmament.
How does gravity work on the flat Earth?
So you just said. Why would the
firmament affect the pressure in the container separate from the firmament?
The same
electrostatics.
way it does.
Dude,
no, it would have no effect. Why would it do electrostatics?
The point is very. Finish off. I want to address what Cole said a little bit before as well.
I want to know why the firmament will affect the density
that wasn't
in
making
another
way
container.
for you. That's not making way for you. Whatever your name, paid NASA show.
Come on, answer the question. You just said that the firmament will affect
NASA. Stop.
Excuse me. You just said
NASA,
that the
stop.
Excuse me. You
NASA,
just said
stop.
Excuse me. You just
please
said
stop,
that
NASA.
Hello. Excuse me.
NASA, please stop.
You just said that the firmament. I'm going to continue this until you just said that the firmament. Excuse me. You just said that the firmament.
Triggered.
You just said that the firmament will affect the gravity in a container.
Melting.
Answer how's it happen? How's it work?
Okay.
It's melting. It's melting.
You have to funny mute me.
NASA.
You have to funny mute me because you can't answer this question.
Mute you in a second.
You can't tell me how the firmament
I will
affect
mute you in a second.
Don't You'll funny gas in a separate container.
You're funny muting the whole conversation. You're a pot calling the kettle black, mate.
Richie, I'm the whole thing turned down since you're constantly interrupting me. I want to.
So NASA Shield, you just said.
No, don't address him. I just muted him. He's got me turned down. He shouldn't have. And I was trying to get in, just to have a quick conversation with Cole about the nature of what he said. There's you're inside of the field of the gravity, and therefore you can't test the gravity. Is that the kind of general sentiment?
And the experiment that he was wanting me to test.
So I'm just going to let you know, dude. I've tried to sort of explain electrostatics. That this gravitational electric force may be attributable to something of an electrical flow from the sky down to the ground. And they said, prove it, show me, test, show me the test, show me the evidence. And I said, you can't really test for this thing because you can't test for an electrical field inside of the electrical field. Have you ever done any electrical voltage testing, or you're trying to work out where a current's coming from, Cole?
I know about electricity.
Cool. So you acknowledge then you need a neutral. In order to detect what's going on one of the lines, you need a neutral. You need to have a known ground figure, right? And it's exactly the same as your what you're saying that the reason you can't test the gravity is because you're inside the gravitational field. It's the same thing. If I equivocate it to an electrostatic phenomenon, but the thing is the Globers laugh at it. They said, oh no, they scoffed and you can't even show us a test. You can't even show, and you're sitting there saying with gravity, you can't show us a test. It's just kind of fascinating that those two things just overlapped with one another, right?
Rich Sky, please can I get in here for a second? Because I do have a video on my channel where a Van de Graaff generator is used on neutrally buoyant balloons to actually pull them down. So what he does is he's got balloons that are neutrally buoyant just levitating above the surface of the ground about 2 inches. And then he adds a positive charge to the balloons and they go down and stick to the ground. He discharges it and it goes back up. And then there's another video where they flip the polarity of the field. They put the negative above the positive. He adds charge now, and the tiny little object in that field goes up because now the negative's up above the positive.
Now make an army tank go up.
Whoa. And then there's another one where a small little object, there's a negative charge added to it, and it levitates because negative and negative repel. So we can actually
Right.
prove it. They can't.
No, you can actually test and see that what's making that happen is it's actually throwing molecules away from it. It's forcing molecules away, which moves it around. You can test for that. But when something is basically dropped, we see that that is not happening. So something else must be causing it to happen.
No, I just said
I told you how to test
No,
this. I
no,
told you,
no.
I told you how to test this.
A test has been done.
You take
Oh my
three
gosh.
objects, equal objects, one positively charged, one neutrally charged, one negatively charged, drop them from, I don't know, say the Leaning Tower of Pisa, this just for historical. And all three of them will hit the ground at exactly the same time, showing that gravity is not electrostatics.
Yeah.
Oh, thank you for proving the gravity formula wrong then.
It's not
So anyway,
electrostatics. What do you mean? I just proved to you that's not electrostatics. They all hit the ground at the same time. That proves gravity.
No, they don't.
Thank you very much. Yes, they do.
Yes, they
No,
do.
so if the object, hang on, you call it an experiment, but it's not an experiment. But the bowling ball and the feather in the vacuum chamber, they hit the ground at the same time, correct?
Yes.
Yep.
Okay, thank you for disproving the gravity formula, because if it's F equals G, F equals G, M1, F equals G, M1 times M2 over R squared. So if mass is the variable in the gravity formula, the bowling ball should have hit the ground faster because it had more mass. Thanks for playing.
Wrong. Because that's
not how
not
gravity
how it
works.
works at all. And you got that formula all mixed up.
That's not how gravity works. So wait, hang on. What's the gravity?
You got that all mixed up.
What's the gravity formula, Cole?
I don't know what the gravity formula is, but I know you have it.
So why did you say I'm wrong then? If you don't know what it is,
because you are wrong.
I've got it mixed up. Well, wait. If you don't know what the gravity formula is, and I do,
because I know how the gravity formula works.
Can I finish? Can I finish? You didn't know what the gravity formula was. I do. So how do you know that I'm wrong about the formula?
Because I know how the gravity formula works.
Gravity is an acceleration, not a force. Gravity is acceleration. Gravity is acceleration, not a force. Gravity is acceleration. You're calculating the force. You're not calculating the acceleration. The acceleration on all objects is 9.81 meters per second per second.
Like a helium balloon that goes up.
The force is greater for something that's heavier, but the acceleration of 9.81 meters per second is exactly the same on all objects.
Really, like a helium balloon that goes up.
Yes, which means that the heavier something is, the harder gravity has to pull on it to get it moving and get it going and pull it down. The lighter something is, the faster and the easier it can pull on it and get it moving and get it pulling down, which makes everything fall at the same rate.
You don't think that that heavier objects fall faster? This has been disproven by Galileo. For fuck's sake, get back into the.
He just said.
Get in the 21st century. This is like a 16th century thing.
That's all. He just said things with more mass fall to the ground, right? So
at the same acceleration, 9.1 meters per second per second.
If I get a helium balloon,
and it goes
up, right, and then I add more mass, to it by adding more helium.
Buoyancy. We know about buoyancy. Buoyancy has gravity in the formula. By what's the formula for buoyancy? Hey, excuse me. You're so big on formulas. What's the formula for buoyancy? Why is there a G?
Can I finish?
Why is there a G in the formula? Why is there a G in the formula? Why is there a G in the formula for buoyancy?
Because little g is acceleration rate.
Exactly. 9.81 meters per second per second.
Right. So does gravity cause things to go up?
Buoyancy, if they're more buoyant, yeah. Because of the buoyancy.
No. Does gravity cause things to go up away from the Earth?
Well, it depends on how you want to look at it. If it's direct gravity, if you have the moon really close, then yes, it could pull things upwards. Or you could say it the other way, and you could say that it.
He doesn't understand buoyancy.
You could say that it causes buoyancy, which pulls the air down.
He doesn't understand buoyancy.
There's more than one force acting upon something. I explained this to you a while ago.
Wait.
He really doesn't understand buoyancy. He thinks that buoyancy only goes downward.
Wait, you know that little g is not gravity, right?
That g is gravity, 9.1 meters per second per second.
G is gravity. Okay, great. So in the buoyancy formula, g is gravity. So does gravity make things go up?
If it's buoyance, yes.
So gravity,
or if it's really close over your head.
Why is there?
Excuse me.
Why is there a G at all? Why is there G at all in the buoyancy formula?
Can I finish?
Why is there G at all in the buoyancy? Why is there G at all in the? Why is there G at all in the? Why is there G in the buoyancy formula?
Is this guy really just being disruptive at this point?
Why is there G in the buoyancy formula?
You see that? No, I'm trying to answer him, but he's just.
No, you're not. He's
a broken record right now.
No, you're not. You're not trying to answer me. You're going to dodge the question now.
Finish.
You're going to dodge. Watch. Okay. How long am I going to let you dodge the question for?
Can I finish?
Why is there G in the buoyancy formula?
The reason why there's a G in the buoyancy formula is because little g is solving for acceleration. Now you just said that gravity is in the buoyancy formula and little g is gravity. So if little g is gravity, does gravity, an attracting a force in your paradigm, make things go up away from the Earth? Does gravity make things go up away from the Earth?
Just a specification. In a buoyancy formula, it's a minus density by acceleration and volume. You have the minus who reverse the direction of the gravity.
Thank you,
so gravity makes things go up in the globe paradigm.
Oh my God, are you really this dense?
You say is gravity in the buoyancy formula?
Gravity's in the buoyancy formula. Yeah, why?
Nico, by the way?
Because you have no gravity, you have no buoyancy. I can show you that. You want me to show you someone manipulating gravity and showing you there is no buoyancy? Let me find that. They go in the bomb.
Please do.
I will.
Yeah, please do. What you're going to do is you're going to show me a vacuum chamber with
nope, not a vacuum chamber. Nope, gonna show you a vacuum chamber with balloons in it. I'm going to show an airplane where they go in a parabolic flight and manipulate gravity so that they're in microgravity.
Gravity makes things go up in the globe paradigm.
Oh my God, are you really this dense?
You say is gravity in the buoyancy formula?
Gravity's in the buoyancy formula. Yeah.
So gravity makes things go up in the globe paradigm.
Oh my God, are you really this dense? Want me to show you someone manipulating gravity and showing you there is no buoyancy? Let me find that. They go in the bomb.
Please do.
I will.
Please do. What you're going to do is you're going to show me a vacuum chamber with
nope, not a vacuum chamber. Nope, gonna show you a vacuum chamber with balloons in it. I'm going to show an airplane where they go in a parabolic flight and manipulate gravity so that they're in microgravity.
Wait. So you're gonna show me in a plane where they go down really far.
Nope, up.
Right,
up,
and that's isolating.
They go up. No, excuse me. They go in a parabolic arc. When the first half of the half of the arc, they're still going up, and they have microgravity.
So you're telling me that when it's the other way around, right? They're going down. They're free falling.
No, they go up. They're in a parabolic arc. The first half of the arc is still going up.
My buddy was here. He knows way more. Nico, he knows way more about it than I do. I don't know if he's still here, but maybe he can answer some of your questions too.
Yeah, he doesn't realize that you're weightless when you're going up.
Yeah,
exactly. That's what I was trying to get at, but I can't get a word in with these guys.
Yeah, you're weightless going up.
I've not interrupted you.
Nacho Shill's literally been on repeat, like he asked the same question.
Because you're not answering my questions. You're dodging them.
See how I did it.
Because you're dodging my questions.
Notice how he's doing it again as I'm trying to explain what he's doing. And
you're not trying to explain it. You're trying to dodge.
See how he did it again? Did you see how he just did it again?
Are you going to dodge or are you going to answer the question?
Okay, so you're removing the acceleration rate and you're trying to say gravity is causing that. How is gravity causing something when you're removing that variable away?
You just said to manipulate gravity, because when here we go. There's the path of the. Excuse me. You just asked. There's the path of the vomit comet. Notice that they're at 0 g for in the middle there. They're still going up for half of it. Why?
Yeah, so you removed the acceleration rate. You didn't isolate gravity to prove it's the cause.
So excuse me. What is gravity? Gravity is the acceleration. Thank you.
Great. So how did you prove that gravity, again, going back to my original question, how did you prove that gravity causes a density gradient by isolating it and
I'm
pulling
removing.
gas?
I'm removing gravity. I'm removing
Is he
gravity.
denying,
The micro-
NASA, is he denying that gravity produces, that acceleration produces a density
Yes.
gradient?
I think
That's quite fast. So I mean, the movement of the Earth it's not negligible. It's basically standing still as compared to our motion at that moment.
That's your experience?
Yeah.
Yeah. Because they tell us, you know, that at least in the U.S., the ground's moving at about 700 miles an hour left to right. And I was thinking that's kind of odd if you're landing going north, you know, or moving in the north direction.
That's not, no, the ground looks to us like it's standing still.
Yeah, not an issue, huh?
Yeah, no.
Well, thank you for your time.
Yeah, you're welcome.
so.
I mean, are you really denying that position? That acceleration will produce a density gradient?
NASA.
No, what I'm trying to say is this guy's they're claiming that gravity is causing a density gradient on Earth. It's holding gas down. But then I asked them,
it obviously is.
in an experiment,
It's literally the reason why. Yeah, you can literally do this in a simple experiment. You could do it with a cell phone inside of a. Moyak did it with a magnet on a cell phone inside a sealed container, because your phone has a very sensitive barometer in it. And what you can do is you can show that at the bottom of the container you have a higher pressure, and you can drag the phone up to the top of the container. It will have a lower pressure, and then you can flip that container upside down, and the pressure gradient will reorient itself that now you'll have the higher pressure at the bottom, which is where the lid is going to be after you flip it upside down, and then the higher pressure or the lower pressure will be at the top. So you can show that gravity is constantly reorienting the gas molecules into a pressure gradient.
You didn't show that gravity caused that. I can show you a gas pressure gradient being made.
Well, if it's not gravity, what's causing the gradient?
Can I finish? Can I finish? I was just getting there. I can show you a gas pressure gradient being made in a container with temperature variations, right? And then I go outside, point to the sky, and say, I can go outside and point to the sky and say, a gas pressure gradient exists, therefore it's contained. Now I can prove my example. You can't prove it's
excuse me. Does gas get more dense or less dense as temperature goes down?
I explained that to him a while ago too.
Does gas go?
It doesn't matter.
It doesn't matter. It doesn't matter. See, gas actually is supposed to get more dense as temperature goes down, but as you go up in the atmosphere, it gets colder and it gets less
thinner,
dense.
Less dense. Exactly.
Why? If it's temperature gradient, if the temperature gradient is causing, it should get more dense, right?
Not to mention, you told me in the very beginning, one of the first things you said was every container, all the gas will seek its equilibrium in a container. You said gas will expand in all directions to fill the volume in a container. Yes. So why does the thick gas near the surface not expand to fill the thin, almost empty part all the way up in the air?
Okay, again, so I'm going to repeat this again. All the gases, are produced at surface level, and then they expand outwards in all directions. As you go higher up, it gets very, very, very cold quickly. And temperature and pressure is directly correlated. It's called Gay-Lussac's law. So I can get a container, cool it down, heat it up in different areas, and have a gas pressure gradient in there. Again, and then I can go outside, point to the sky, and say, oh, look, a gas pressure gradient, therefore it's contained, and I can prove my example. You guys are claiming that gravity is causing the density.
I just gave you the example of a sealed container on your desk, and you can flip it over, and in 1 second, the pressure gradient will shift.
You guys are claiming that gravity is causing that, yet you can't prove it. You can't.
Yeah, I just told you the experiment. I just told you the experiment to demonstrate that. In a sealed container.
What's the independent variable? What was the independent variable of that experiment?
Can I?
The position of the container.
Here we go. Thank you,
QE.
Oh my God! So you're gonna go back to
So before you go, Nico, let me just say one thing real quick. You're sitting there. We just told you that when gas gets colder, it gets thicker. When it gets warmer, it gets thinner. And then you sit right there and say that as gas goes up and it gets colder, what'd you say? It gets thinner. You said you said as it gets colder, it gets thinner or something like that. You said the complete opposite from what we see. As you go higher up and it gets colder, the air should get thicker, And as you're down on the surface, it should get thinner, because you even said you can apply heat and cold and show that pressure's directly related to heat and cold. Yeah, you know why pressure is related to heat and cold? Because when you heat a gas up, it expands. Which means it causes higher pressure. When you cool it off, it contracts, which means it causes lower pressure. So the colder air should be lower, but it's not up high. The higher you go, the lower it gets, but it's thinner. That makes no sense. That goes completely against what you said. Entirely 180 against what you said.
Great. So again, I'm going to repeat myself again. As you go higher, the temperature decreases rapidly. And when temperature decreases rapidly, gas molecules don't move around as much. They create less collisions with the container.
Which means they get more dense.
So when they create less collisions with the container, there's less pressure. Do you agree with that?
There's less yes, but do you know why that there's less? Do you know why? Hold on. We got to clear this up. We have to clear this up. Do you know why that there's more collisions with the container when you have higher pressure? When you heat them up, because they move more, they expand further apart, and they collide more with the container. But that's warmer. When you cool them off, and when you cool them off and they slow down, they get closer together and they condense. They don't get thinner like we see in our atmosphere. The higher you go, the colder it gets, but the thinner they get thicker. But you're saying that you're backwards from it. What you're saying is completely opposite than what we see in reality.
Right, but again, I can prove a gas pressure gradient. I can prove a gas pressure gradient. I can prove a gas pressure gradient inside of a container. Can you prove a gas pressure gradient with gravity, please, in a container?
Yes.
Great. Show me someone using gravity to manipulate the molecules in a container to cause them to go down to the bottom of the container. Can you show me that?
Yeah. All you have to do is basically take any type of container, and once you stand it up, it'll have a gradient. And if you drop it, when you drop it, all of a sudden it doesn't have the pull of gravity on it. It's free falling. So it no longer has that gradient, which means when you took that gravity away, the gradient went away. But when it hit the ground, guess what? The gradient comes back, showing that when gravity came back, the gradient came back. I manipulated gravity, and at the same time it changed the gradient.
So are you claiming that the Earth is falling down and that's why there's a gradient? Because that's what you just said. You said you can move the container down and create, and then it disperses.
No, that's the way I manipulated gravity.
Hang on a second.
You said you wanted me to manipulate gravity. That's how I manipulated gravity.
That's not manipulating gravity. You'd need to isolate gravity, get a container, and move the gas molecules down with gravity, pulling them down. So, what's the independent variable for that experiment that you
all I had to do is get rid of gravity, and I did that by dropping the container.
So you're assuming that gravity exists in the first place, and then by moving the container, it's going to do something. How did you isolate gravity to prove that?
You didn't isolate gravity. I got rid of gravity by dropping the container. I got rid of gravity. I didn't have to isolate it. I removed it.
So then, how do you know that gravity caused that if you didn't isolate it?
You don't have to isolate it. I removed it.
Yes, you do.
I removed the force pulling down. You can call it gravity. You can call it dropping it. You can call it stupid downward force. I don't care. I removed it. And it shows that when it's not there, when the force pulling down is not there, the gradient is not there.
But you didn't prove that the force pulling down is gravity.
It is gravity. We call gravity the thing that pulls things down. That? So no matter what you want to call it, whatever pulls things down, that's what we call gravity.
Again, a helium balloon doesn't fall down, my friend. Okay, it goes up.
Because other forces act upon it.
Right.
I've explained this to you tonight.
I've done an experiment before where I filled a balloon half with air, half with helium. Do you agree that a half-filled balloon with helium and air has mass?
Yes.
Why did it levitate then?
Because it's equal
because
to
it's still displaced. As long as it displaces,
right?
It displaces an equal weight of air compared to the weights that it is. It will be neutrally buoyant.
And also
Right.
the
So then
rubber, the rubber around the balloon has weight. So as long as the helium inside pushes up at the same as the air and the rubber that makes up the actual balloon is being pulled down, it will stay this. It'll float. It'll stay the same. You can't leave out the weight of the rubber.
You know, you
which
can
I
do that
think
with
is what you
electricity.
did.
You know, you can do that with electricity. You can do exactly
Yes.
what you're talking about with electricity, man. You
Yes.
say that you let go, you put it into free fall. All you
You're
have to do
using
with
other
electricity.
forces at that point.
No, they're compatible, dude. So, okay, for example, if I took a magnet and put it through a copper tube, right? That it slows the magnet down. You're familiar with that effect?
Yes.
Cool. If I drop the copper tube at the same time with the magnet inside, what happens? Nothing.
I don't know. I've never
You're
done
getting
it.
rid
I
of the
don't know.
resistance. Yeah. So if you drop it, it's just like getting rid of the resistance. Like if you've got an electrical circuit and you get rid of the resistance such that it's just always grounding, and you go like search off somewhere else down the lead line, you won't find the 12 volts that you're looking for.
To
You just won't find it.
begin with, Risky, they both fall at the same rate. So if you drop both of them at the same time and one inside the other, they should fall together at the same time. Because if you're holding one and you drop the other one, if the gravity's going to try to pull it down, but the other forces acting upon it is going to try to resist that. If you drop them both at the same time, they're both going to fall at the same rate. There's not going to be any one falling through the other.
All I'm trying to show is how do you get.
It is the falling. It is the falling of the metal in the copper tube. So you should have a relative acceleration between the tube and the metal. When you drop your pipe with the metal in it, you don't have this difference of speed. What creates the force that slow it down? It is the metal ball compare with the tube. If they are both falling at the same speed, there is no movement, so there is no force slowing it down. They would just fall at the same speed.
Yeah, there's no force generated because one's not moving through the other. Whatever. Good job, Nico. I liked it.
Movement, so there is no force slowing it down. They would just fall at the same speed.
Yeah, there's no force generated because one's not moving through the other. Whatever. Good job, Nico. I liked it. Through the other. Whatever. Good job, Nico. I liked it.
So again, you can't verify in an experiment that gravity proves anything because you can't isolate gravity, right?
I isolated gravity a while ago. I got rid of it for you. I did better than isolate it.
No, but you don't know that gravity's pulling things down. You haven't isolated.
I call whatever causes things to drop gravity. You can change the name and call it dropity or whatever you want. It's whatever makes things fall.
Great, electrostatics, yeah. Because we have an electrostatic gradient.
We know it's not electrostatics because we can remove electrostatics and they still fall.
Right. So you can't remove the mass of the object, and the mass is held together with electrostatics. So you can't remove electrostatics actually completely. But anyway, do you agree? Hey, Cole, do you agree? Right? Do you agree that the sun's the surface of the sun is about 10,000 degrees? And if you were to move the surface of the sun to touch the Earth, it would vaporize the Earth because it's so hot.
Probably, I imagine. Probably be pretty bad day.
Okay, great. So you have the core of the Earth, which is as hot as the surface of the sun. How come it doesn't vaporize the Earth like you just said it would?
Because there's a temperature gradient.
It's insulated.
No,
it's insulated. That's a good point too. And it's insulated by the crust.
If you can insulate a house by just putting 2 or 3 feet of soil on the top,
something right? Because he's got an astronaut photo on his thing, right? So hey, Cole. So if he's pressurized suit, right? If that glass on his pressurized suit breaks, what happens to the gas he breathes in a vacuum?
It expands to fill the space.
Expands out.
Okay, so if that's true, then, and you've got an Earth with gas around it, gas pressure gradient or not, and it's an infinitesimal small dot in an infinite vacuum, will the gas pressure seek equilibrium the same way?
No.
Yes.
No. Okay, so you're an entropy denier. So okay, great. So you're just an entropy denier then.
No.
It will, and depending on which type of gas is it,
Do you think that the Earth, being an infinitesimal small dot in an infinite space vacuum, is in equilibrium in gas pressure?
Okay,
no, do you think that
you're giving examples
that
are not? You're trying to come up with ideas that aren't analogous with the Earth.
This is why I'm asking you.
It isn't a gotcha moment to say that gas inside a vacuum, if you just have a little container and then you release the container
and really high pressure of gas,
and then the gas is going to expand. That isn't analogous to the Earth. It doesn't give you what you think it gives you.
Well, he's just trying to say there's not only one way to skin a cat. You just can't have a spinning sphere with this imaginary core that creates gravity because of mass or whatever you want to say it does, that keeps the gases creating a gradient up to 20 miles.